today we move on to 3.6. And before we can introduce our final method for solving systems, we have to talk about some basic things first. So 3.6 is matrices. Matrices. All right, so first of all, I want to tell you about a matrice. A matrice is, it kind of looks like a box of numbers, but it represents things, okay? So it's how the box of numbers and what it represents. So now, if it has a box, okay, anyway, this way is always our rows. And, of course, going up and down are columns, right? Every element has a name. The first spot, if this was matrix A, this would be A11. That spot would be row 1, column 1. This spot would be A12, row 1, column 2. And then A13. Okay? So then the second one would be A21, row 2, column 1, 2, 2, 2, 3, very good. And if we had a third row, it would be 3, 1, 3, 2, and 3, 3. So with that being said, example number 1. Well, okay. Identify the element. Okay? And let's say I give you a matrix that looks like 1, 2, -5, 6, 1, 0, 9, -3, 7. And I asked for A31. What is it? 9. Very good. Let's say I ask for A23. 0. 0. How about if I ask for A13? Perfect. How about if I ask for A32? -3. Very good. This is a start. This is the beginning. So I said that a matrix represents things. One of the things it represents is a system. Okay? So a matrix that represents a system it's a coefficient matrix. We are going to use the coefficients of each variable. So let's say I have a system, let's go 2x plus 3y equals 6 and 5x minus 9y equals 2. The coefficient matrix that represents this system is literally 2 for the coefficient on x, 3 for the coefficient on y, and 6 for the coefficient of the answer. Second row is 5, -9, and 2. Now this book likes to put a line right here. You might have noticed a line in it, representing the system from the answers. Okay? So here is example number 2. All right. So on 12 through 16, state the coefficient matrix for the system. X plus y plus z equals 4. Negative 2x plus 5y minus z equals 2. And then 6x plus y plus 2z equals 3. I figured I could up it because you guys can handle this. All right, so we put our bracket. We have 3 equations, which means we will have 3 rows. So little dashes there to help me remember there's 3 rows. My coefficients in the first one. How many x's do I have? How many y's? How many z's? And I'm going to put that line down to help with the answer, equals 4, right? Second equation, I have negative 2x, 5y, negative 1z, and 2. And my last equation, I have 6 plus 1. Oops, I don't know why I put a plus there. Sorry, my bad. 1 plus 2z equals 3. There is. All right. Which we will get to soon. So what do you think if I wouldn't have had this term there and it just was like y plus 2z? What number do you think goes here? A 0, exactly. So like the ones you had yesterday when they didn't have anything, you could have put a 0 in your matrix to represent that. Okay? Example number 3. Oh, we're just cruising, aren't we? Example number 3. And this one is 18 to 22. Write the system represented by the matrix. Say I have 2, 7, 3, and let's go negative 4, 5, 1. All right. So you know on the right side of where this line is, this book likes to put a line there, represents the equal sign, so to speak. And we have 2 variables here. We're going to use x and we're going to use y. If there was 3 columns there, we'd do x, y, z, right? Okay, so our system, we start here, we have 2 x's. We have plus 7 y's, and it equals how much? Perfect. Next one, negative 4x. Good? Perfect. That wasn't so bad, right? Not yet. We got a little bit more to go. Just want to start it off nice and slow. Okay, so I want to do one more in here. It's going to lead us to the next thing. What if you had this matrix? 1, 0, 7, 0, 2, 9. Nope, 0, 1, 9. We'll go 1 here. My bad. What do you think this represents? X equals 7 and y equals 9. Exactly. So this is what we call an identity matrix, where you have 1s in the diagonal that represent 1x, y, if we had another one, it'd be z, and 0s everywhere else. So this tells you what our solution is. Okay? When we get done today and you're solving a system, we're going to have an identity matrix that tells you that x equals 7, y equals 9. Okay? Everybody's got that? We're good? Okay. So that being said, we're going to talk about how to use a matrix to solve a system. Now, everybody has to have a calculator in their possession right now. Everybody's got a calculator? All right. First, we're going to change this system into a coefficient matrix. So step 1, change to coefficient matrix. All right, and maybe this system is A plus B plus C equals negative 3. 3B minus C equals 4. And 2a minus b minus 2c equals negative 5. All right, so as a coefficient matrix, we have what across the top? 1a, 1b, 1c, and it equals? Good. All right, next one I have 0 a's, 3 b's, negative 1c, and it equals 4. Last one, we have 2. Good. Good. Perfect. All right. So step 2, we're going to go into our calculator. We're going to grab our wonderful calculators. You're going to go into matrix. So you have to hit second and x to the negative 1. So go to calculator. All right. And we're hitting second. And it's x with a little negative 1 exponent on it, that button. You'll notice in blue right above that it says matrix. It does. All right. Move that up just a little bit. Not quite that far. Okay. So everybody hit that. Now I need you to push step 3. Push to the side to over to math. And down to RREF. And hit enter. I believe that is capital B all the way down. Yeah, capital B. All right, hit enter. You should get RREF with a parenthesis flashing on your screen. Everybody has that? Okay. Next, step 4. We're going to go alpha and F3. The green button. F3 is across the top, the middle one. Okay? You should have 2 columns that come up. Yeah. Yes. You should have 2 columns come up. Now, that first column, we need to click on, this is 3 rows. So you're going to go up in the first column under the word row and click on 3. Then you're going to go over to the columns. And in this case, how many columns do we have? We have 4, correct. Enter, and then I need you to go down to OK. Step 5. What? Okay, go ahead. Come in. Huh? You push your little scroll thingy up and down. Push up.
Yeah, it's not moving.
Yes, it is. Go up.
Oh.
3. Hit enter. Okay. You did second alpha. Oh. Okay. Let me just reprogram yours real quick. Did you get it? Okay. Now go down to OK. And hit enter. Perfect. Go to row 3. There's 3 rows. And then you hit enter. And then you go to column 4. Hit enter and then go down to OK. Okay, so you should see a matrix that comes up on your screen. We are now going to enter our matrix. All right, let's see. Yep. Just trying to get him back to where. Just 1 second, please. I'm trying to do. There you go. All right. So now you should see all of the elements in your matrix come up. So step 5, you're going to put in your matrix. You have to push to the side to enter each one. Okay? Once you have it all filled in, you're going to push to the side to get out of your parentheses and hit enter. And in that third column, you should have gotten -3, 1, -3. Okay. So I'm going to walk around, make sure everybody was able to put it in, was able to get out this identity matrix. What we just did was number 12 from yesterday's homework. Okay. All right, so you put them all in, right? Okay, now you're going to push to the side to get out of here. And you just hit enter. So that just says x equals -3, y equals 1, and z equals -1. Yeah, right. Okay. Okay, so listen up while I keep talking real quick. So here, obviously this says once you get this identity matrix that x equals -3, y equals 1, and z equals -1. Or you can literally take this point and write it as a point, -3, 1, -1. Okay? We're going to try one more real quick so we can practice doing that. All right, let's try one more. So let's make it example number, what am I on? 4. Example 4. This is actually the rest of your problems are solving the matrix. Let's do 3x minus y plus z equals 3. We'll do x plus y plus 2z equals 4, and x plus 2y plus z equals 4. So the very first thing we have to do is our coefficient matrix. 3, -1, 1, 3. All right, the next one would be 1, 1, 2, 4. Then we have 1, 2, 1, 4. Okay, so go into matrix, go over to math, go down to RREF, make sure you hit that first. Then you go to alpha F3. This again is a 3 by 4. Make sure you push out and then hit enter. No.
This is supposed to be 1, 1, 1.
Yep. So you must have put one number in wrong, Evan. Yes, this should have gotten the answer. 1, 1, 1. Okay. This was number 16 from yesterday. Okay. So check your numbers. Kaylin, you probably just missed a negative or hit something wrong in there. Oh. All right. Questions. Anybody got any questions on how to do this? Told you, some of you were going to like it right away. Some of you might need a little more convincing. But It really does make life easier. And actually, you can solve any system now, any size system now, and you can use this on the SAT. Okay. All right.
Like creates my hand from so much writing and work and less room for